I'm going to continue with another example of function composition, and I'm going to start right away with a question. My goal is here. I'm going to find gf of g of x, but now regarding f of g of x, the question is what would be its domain here. Now, in order to get to this solution, an easy way would be, okay, let's get to input a g of x on f, and let's get to the compounded function, and then let's see the domain of the result of this compounded function. Well, actually, that wouldn't be correct all the time. It might work sometimes, but in many other cases, it won't. So the right approach would be to get to the domain of the input function, in this case, g of x, and then include that domain in the compounded function. Now, I'm going to paste here on the left this 4 steps, a recommendation in order, or a guide to get to solve these kind of problems here. The first step will be find the domain of the input function. That's where we're going to right now. The second step will be find the compounded function, which is what we had done on the previous examples only. Now, find the domain of the compounded function and then include both domains in the final solution. So let's get to the first one, the first step. Find the domain of the input function. The input function in this case is g of x. So in this case, g of x is equal to 1 over x minus 2. That is to say that what's in the denominator cannot be equal to 0. I'm going to write it in here. X minus 2 must be different to 0. Now I'm going to add positive 2 on both sides of the equation, and we'll get to this. X different than 2. In other words, the domain of g, I'm going to write it like this, a capital D, and then a sub-index of g. We have, in order to be clear which domain this is, the domain of g would be all the real numbers except for number 2. Now here, you may have seen other notations to write domains. Feel free to use the one you feel more comfortable with. I'm just going to use the one that, in my opinion, fits better in each case. So we got here the domain of the input function here. That would be all for the first step here. Now, let's go to the second step. Find the compounded function. Okay, so let's get to business here. I'm going to write it in here. F, we have to find f of g of x. So what is this f of g of x? I'm going to write here what is actually g of x, x minus 1 over x minus 2, and I'm going to substitute that in every x of f. I'm going to do it like this. 1 over x minus 2 here. Now I'm going to continue here to do the algebra here in order to solve this out, to find, to simplify this. So I have here 1 over x minus 2, and this one on the right, I'm going to multiply it by x minus 2 over x minus 2. Now, I'm going to get here x minus 2 over x minus 2. Now I'm going to get together the denominators, and we get to this expression, 1 plus x minus 2 on the middle. Simplifying this out, I will get to, in the middle, x minus 1, and then at the bottom, x minus 2. Now, here I'm going to use a, okay, but first I'm going to explain a bit further this. I don't know, this, what I've done here, could be seen, in case you don't remember the algebra that well, would be something pretty similar to do this. 1 over 3 plus 1 and then I will multiply, in order to get along with this operation, I will multiply this one by 3 over 3. Now here in step, I will get 1 over 3 plus 3 over 3, and then I will get here 1 plus 3 over 3, and then at the end I will go here to 4 over 3. Okay, this is what I just did here. I'm going to continue where we left. Here we have to use this super famous, the sandwich rule. It will be 1 over 1 over x minus 1 over x minus 2 here. I'm going to multiply these 2 and these 2. And let's see where I can continue. I'm going to continue here in the middle. Here in the middle will be f. I'm just going to write the same original statement, just so we get clear what we're doing. Would be f of g of x would be just the same as saying x minus 2 over x minus 1. And here we are already done with the second step, because this is actually the compounded function. In other words, we are getting along just right with this one, the second step. Here is our compounded function. Now let's go to the third one, the third step, and find the domain of the compounded function. That is pretty similar to the first case of g we found. So I'm going to get it here. I'm going to use a different color. Let's make it with orange here. Here, this x minus 1 cannot be equal to 0. So in other words, x minus 1, it's different. This is 0 here. So I'm going to add 1 in both sides of the equation and get to x different from 1. In other words, the domain, I'm going to use the same notation. I'm just going to write like this: f of g will be equal to all the real numbers except number 1. Now notice something. Okay, first we got along with the third step. Notice something here. The domain of g, it's all the real numbers except number 2. The domain of f of g is all the real numbers except for 1. You can see they're not the same. So in order to write the final solution, we have to include both of them in our solution. I'm going to write it here in the middle, using this color here in the middle. So will be the final domain. I'm going to write like this, a d, just without any index, just to make clear it is the domain we're looking for. Would be the domain, would be all the real numbers except for 1 and 2. And by that, we just completed the fourth step here, and that would be basically all here. Now, just briefly, remember what we have done here. We started by trying to answer the question, what would be the domain of a compounded function? So we followed these 4 steps on the left. We first found the domain of the input function, which is this one here. Then we found the compounded function, which is this one here, f of g of x equal to x minus 2 over x minus 1. And then we found the domain of this compounded function, which is this one here. The domain of f of g are all the real numbers except for 1. Now, for the final solution, which is this one, we included both restrictions in this solution. It will be the domain will be equal to all the real numbers except for 1 and 2. And that will be it. Okay, let's go to another example.